Today's date is January 13th, 1969. Although the stereotypical image of the US West Coast is often one of tan bodies basking on sun-drenched golden beaches, in the Pacific Northwest at least, such is often far from the reality. Particularly at this time of the year, temperatures in the area seldom rise above single digits on the centigrade scale, with at least every second day recording some level of precipitation falling, and on those colder days, often as sleet or snow rather than simply rain. Indeed, such was the case during the early weeks of '69, as Scandinavian 933 was being prepared for departure from Seattle's Tacoma International for the relatively short hop south to the warmer climes of California. The aircraft, a DC-8 62 series, had arrived into Seattle earlier that same day from Copenhagen, Denmark, with the inbound crew subsequently disembarking to allow for a scheduled crew change prior to the aircraft's onward final sector to Los Angeles. The joining crew, rostered to operate the final domestic sector south, would be led by one Captain Kenneth Davies, aged 50. Davies, a British national, had previously held the rank of squadron leader in the RAF Coastal Command, and at the time of the accident had accumulated a total of more than 11,000 total flying hours, 900 of which had been logged on the DC-8 type. To his right, and occupying the co-pilot seat, would be First Officer Hans Ingvar Hansson, aged 40. His total experience amounted to just under 6,000 hours, with a similar level of experience on the DC-8 as Davis, having logged a total of 973 hours on the type. To the rear of the cockpit and overseeing the flight engineer's station was Second Officer Ake Ingvar Andersson, aged 32. Considerably less experienced than his colleagues, Andersson had logged a total of just 985 hours of total flying time, all of which had been gained on the panel of the DC-8. The 3 pilots and 6 accompanying cabin crew had arrived in Seattle 2 days earlier on January 11th, and now, well rested, had reported for duty at Tacoma approximately 60 minutes prior to the flight's scheduled departure time of 14:35 local. As is customary, the crew reviewed the relevant pre-flight documentation while communicating over the phone with the SAS dispatch personnel based in Los Angeles. Davies learned that having assessed the overall weather situation for the California area, the dispatcher assigned to Flight 933 had considered it prudent to reduce a flight plan from Seattle to Los Angeles, with Las Vegas, Nevada as the designated first alternate, should the flight for whatever reason be unable to land at its destination. Apart from this, he also noted an average headwind component at the planned cruising level of 33,000 feet of approximately 50 knots, pushing the expected time en route to a slightly longer than usual 2 hours and 16 minutes. This flight time, plus the alternative reserves, necessitated the minimum upload of 22,700 kilos, or the equivalent of 50,000 pounds of fuel. However, anticipating the possibility of inbound delays into Los Angeles, in addition, the dispatcher had factored in extra holding fuel, bringing the suggested target to 25,000 kilos, or the equivalent of 55,000 pounds. Obviously, the final decision on whether to accept this recommendation or to ultimately take more or less fuel was a decision for Davis alone. But given the weather forecast for their expected arrival time, he was more than happy to accept the dispatcher's recommendation. What the forecast indicated was that for the afternoon of the 13th, Los Angeles was to experience an overcast ceiling at 3,000 feet, with visibility of in and around 5 statute miles. However, from time to time these values could be expected to worsen, with ceilings of 1,500 feet and visibilities of 2 miles in rain or fog, more than likely. A long way from the stereotypical images of California's blue skies and glorious sunshine. As if to corroborate what was being forecast on paper, less than an hour before departure, the dispatcher in Los Angeles contacted Davis to inform him that pilots inbound to Los Angeles had already begun to report solid overcast conditions between 17,000 and 9,000 feet in the descent, with rime ice being reported in areas to the north of the airport, the exact direction from which 933 would eventually arrive. Davis and his crew acknowledged the dispatcher's report and finalised their preparation for departure. With doors closed, the total head count on board for the final short hop to Los Angeles now revealed a total of 9 crew and 36 passengers. Given the conditions, despite being closed up and ready to go, 933 required de-icing, a process whereby the accumulation of snow and ice which had settled on the aircraft during its short time on the ground in Seattle would be removed and the airframe subsequently protected against further contamination until such time as it could safely get airborne. But all this would take time. So having finally completed the process and commenced taxi to runway 16, Scandinavian 933 would eventually receive its takeoff clearance and become airborne at 15:46 local, just over an hour and 10 minutes behind schedule. It had been decided in advance that First Officer Hansen would fly the aircraft to Los Angeles, so it was he who climbed the aircraft to its cruising flight level of initially 310 and then subsequently 330, or the equivalent of 33,000 feet, as the jet followed the Pacific coastline south overhead Portland, Sacramento and Bakersfield, just to the northeast of Los Angeles itself. In the background at 1700 local, approximately 1 hour 15 after 933's departure from Seattle, the original company dispatcher who had been overseeing the flight was relieved of duty for the day. Prior to his departure, per standard procedure, he briefed his replacement on the local weather situation over Southern California and its potential for inbound delays into Los Angeles International. It was noted that geographically, the closest airport to Los Angeles, Ontario, some 76 kilometres to the east, was now below operational limits. What this meant was that should 933 be unable to land at Los Angeles for whatever reason, the weather at Ontario would prohibit its usage as an alternate. Las Vegas, on the other hand, was still holding up pretty well, and although much further away, had been accommodated in Davis' fuel planning from the very outset. As such, 933's fuel endurance, in light of this potential disruption, was discussed between the two dispatchers, with the oncoming dispatcher subsequently taking over responsibility for the flight from in or around 1715 local. All in all, a fairly routine handover, with nothing exceptional being flagged for special attention or concern. Despite the cruise portion of the flight being largely uneventful, it became apparent that apprehension about the progress of the flight was growing on the flight deck. Not only were they considerably behind schedule due to their delayed departure from Seattle, but having calculated a ground speed check en route, Hansen had discovered that the anticipated 50-knot headwind they had planned for was in reality more like 110, and this significant increase above what was planned for would have a detrimental effect on the aircraft's fuel burn. An additional 50 knots of headwind would now extend the expected flight time still further, from the initial planned 2 hours and 16 out to beyond 2 hours 25. This additional en route time and associated extra fuel burn would compromise their holding reserves should they be needed later. To put it in context, the extra fuel now being burnt en route would have allowed for approximately 20 to 30 minutes of additional holding time, but that was now gone. Although less than desirable, the situation was far from critical. It simply meant that should there be disruption inbound, Davis would now have to make alternative plans sooner than he might have initially been expecting to. Just after 5:30 in the afternoon, Davis contacted the initial Los Angeles approach controller, who cleared the flight to proceed directly to the Bakersfield navigation beacon and enter the published hold once overhead, while maintaining its cruising altitude of 33,000 feet. Proof positive that traffic up ahead was starting to back up. Some 15 minutes later, the company dispatcher was notified that 933 was holding overhead Bakersfield, with Davis contacting him directly on the company frequency. While doing so, he also sought confirmation of the exact fuel requirements to reach Las Vegas. In reply, the dispatcher confirmed that assuming that the diversion to Las Vegas was to commence from termination of the approach into Los Angeles, by his calculations, the crew would require a minimum of 7,400 kilo, or the equivalent of 16,300 pounds of fuel. A quick look at the jet's fuel gauges and their own independent evaluation had all three of the crew members in agreement that the current fuel load would allow for the best part of an additional 60 minutes holding before that decision would have to be made. Shortly after, at about 1840 local, Scandinavian 933 was cleared to leave the hold at Bakersfield, continuing to Fillmore, another navigation beacon somewhat closer to Los Angeles International, with progressive descent clearance being issued as it went. Although 933 was instructed to enter a second holding pattern on reaching Fillmore, Davis and his crew were nonetheless relieved. This was progress, albeit slow. Descending as it proceeded south, 933 finally entered the adverse weather conditions which had been reported earlier in the afternoon, as the storm clouds ahead enveloped the DC-8 and raindrops peppered the jet's fuselage. Established in the hold at Fillmore, it wasn't long before the approaching controller called 933 once more, with additional instructions.
Scandinavian 933, you're cleared to the Los Angeles airport via Fillmore, Fillmore 158 radial, to intercept and proceed via the back course ILS to runway 07 right. Cross Fillmore 11,000, cross the Ventura 100 radial at and maintain 5,000.
Davis' reply was somewhat hesitant, and revealed a certain level of confusion on the captain's part.
Clear to Los Angeles International, 158 radial to the back course for 07 right. Leave Fillmore at 11,000, and 100 radial at 5,000.
Davies' hesitation was likely the result of trying to mentally process the complexity of the clearance he had just been issued. But undoubtedly, he was also thrown off guard by the controller's intention to have him shoot the back course ILS to runway 07 right, a specific instrument approach which Scandinavian Airlines had prohibited its pilots from executing at Los Angeles International. The controller, sensing an element of ambiguity in Davis' voice, quickly moved to clarify.
933, that's the Ventura 100 radial, Westlake intersection, at and maintain 5,000.
Davies acknowledged with a monosyllabic,
Roger.
The Westlake intersection wasn't depicted on any of the crew's charts, as it had only been commissioned as a navigation fix in the days immediately beforehand. This in itself was nothing more than an inconvenience really, as the controller's initial instructions had been more than adequate to get the job done. Undoubtedly, however, what was of more concern to Davis was the issue of the back course ILS. Shooting this approach to 07 right simply wasn't an option. The crew didn't even carry the relevant approach charts on board the aircraft, so Davis was now under increasing pressure to find an alternative, and quick. The following brief presentation explains the unique idiosyncrasies which make this specific approach procedure different from other conventional ILS approaches. Idiosyncrasies which, for the majority of cases, render these approach types redundant in pretty much every other corner of the globe, with the exception of the United States.
The main component of an ILS approach is the localizer transmission, which provides lateral guidance to the runway. It does this with a pair of highly directional radio transmissions, one at 90 Hz, the other at 150 Hz. Where the two signals overlap, an aircraft with the proper receiver will have indications showing on the extended center line of the runway, as this VOR receiver does by having the vertical needle centered. In addition to broadcasting this signal on the approach side of the runway, which is known as the front course, the localizer antenna also broadcasts the same signal in the opposite direction, with the 90 and 150 Hz transmissions on opposite sides. Where these transmissions overlap is known as the back course. Both the front course and back course are represented by these feather symbols. In addition, the side with the 150 Hz transmission is given a shading like this. We know that a front course is flown by starting out on an intercept course like a vector that ATC would provide us. Initially, the aircraft here on the right side of the localizer course would have these indications: the localizer needle to the left and the glide slope needle above center. As we approach the extended centerline, we enter the feather and the needle begins to move towards center, centering up when we're perfectly aligned. As we continue inbound, we intercept the glide slope from below so that needle moves down to center as well. This is how the ILS localizer front course is flown. Now, let's say we get a bit off course to the right side. It happens to the best of us, and we get the indication of the needle swinging to the left. As we continue inbound, we're not stabilized for landing, and we'll need to do a missed approach. As we maintain this course past the runway, the needle stays to the left. Notice the 2 flag remains on even as we pass the approach end of the runway. This is because the localizer antenna is located at the far end, the departure end of this runway. So it's when we reach the antenna that the flag flips from to from. We're now picking up the back course transmission. As we continue to fly out, the needle stays on the left side of center. Let's look at what our receiver will show us in this case. First of all, if there's one thing you remember about localizers, and about VORs in general for that matter, it's that the indication on the receiver stays the same regardless of aircraft heading. We can spin around in circles, and as long as we stay in this position on this side of the feather, the indication won't change. Also, notice that the needle has remained on the left side throughout this exercise. No matter what then, as long as we're on the shaded side of the feather, as we are here on the back course, as well as when we were on the front course, the needle will be off to the left, and vice versa. On the other side of the feather, the non-shaded side, the needle will always be to the right. And again, this is totally not dependent on aircraft heading. If you can remember these points, it'll help you grasp the somewhat difficult topic of the back course. So why would you fly a back course? Well, some airports use a back course in an instrument approach procedure. There's a few dozen of these throughout the country. Here's an approach plate at Mesquite Metro in Texas. This is the localizer back course approach to runway 36. It uses the same localizer antenna as the ILS approach to the opposite runway, 18, uses. So why not just build a second localizer for runway 36? Well, it could be a cost-saving measure. Maybe the prevailing winds favor runway 18, so it didn't make sense to build a second localizer in the off chance you'd need to use 36. Anyways, at first glance, this approach plate looks deceptively similar to one for a standard localizer front course approach. So here's where we can see it's actually a back course approach. First of all, the procedure title spells it out by saying Loc DME BC back course runway 36. Next, they've actually called out back course here on the plan view section of the plate to further distinguish it. Another difference is that in the profile view, they've indicated that the glide slope should be ignored. You may receive a glide slope indication, which could be false or not, but in any case, it's designed for the opposite runway, not this one. A localizer back course approach is a non-precision approach. There's no vertical guidance. And you can see that in the minimum section where the decision height is 437 feet AGL. This is more than 200 feet higher than the standard height for a precision ILS approach. Finally, we can see that this is a back course because that shading indicating the 150 Hz signal is on the left side of the feather, not the right side as we'd see on a front course symbol. Notice the initial indications on the receiver. First, we're going to ignore the glide slope needle, so it being above center means nothing to us. Next, the needle is to the right. This is not what we'd see on the front course. Rather than chase the needle, we need to fly away from or pull the needle by flying left of the approach course. This is what we're already doing. We're on a northwesterly heading to intercept the approach course, so as long as we hold this, the needle will center up, and we're flying away from the needle. So we intercept the back course, turn inbound on the approach course. Now let's see what happens if we get off course. What if we get blown to the left of course? What will the needle do? We'll be on the shaded side of the feather, so the needle will swing to the left. Normally we'd fix this by chasing the needle, but we're driving a back course, so we'll need to fly away from the needle to the right to get it centered again.
Given that the back course procedure for runway 07 right was prohibited, Davies instead decided that they would fly the VOR approach without authorization to do so, or even making a request that such an approach be made available. unlike the back course, which, for all its failings, does actually provide accurate lateral guidance once the reverse sensing phenomena is understood. The VOR approach is inherently much less accurate in the lateral plane, while both, being non-precision approaches, lack any clearly defined vertical profile which can be readily followed by the pilot. Thus, the very nature of these approach types make them extremely prone to piloting errors, particularly in the vertical plane, with associated higher than normal demands on cockpit workload. With the aircraft getting ever closer to Los Angeles International, this is exactly what was now transpiring on the flight deck of 933. While 933 was descending from 11,000 feet, having passed the Fillmore navigation beacon, the approach controller instructed Davies to slow his aircraft to 160 knots, this to facilitate separation from other inbound traffic up ahead. With Davies acknowledging the request, Hansen called for the extension of the trailing edge flaps so that he might achieve the lift augmentation required in order to fly at the slower speed. Conditions outside were described as black and featureless, with nothing visible of the normally impressive Los Angeles cityscape after dark. By the time this request was made, the crew of Scandinavian 933 had begun to execute the items listed on the standard approach checklist. However, perhaps being somewhat premature, Davis had decided to interrupt the check and pause procedures while he awaited indication that the radio altimeter was working properly. Unlike the normal barometric altimeters used on board, which are sensitive to atmospheric pressure, radio altimeters emit a radio signal to measure in real time the height of the aircraft above the terrain profile immediately below the aircraft. With limited signal strength, presentation of height above terrain is only displayed to the pilots when within 2,500 feet. As the aircraft hadn't descended that low yet, Davis had chosen to pause the check and wait for this to happen. Considering that the instrument would take on additional significance this evening, given the low cloud base and inclement weather conditions. Just after 7:10 that evening, 933 was vectored onto a southerly heading, with further descent clearance at 3,000 feet. In preparation for the VOR approach, Davis tuned his navigation receiver to the relevant Los Angeles navigation beacon, a frequency of 113.6 MHz, and set the appropriate inbound course, which would provide the all-important lateral guidance to the landing runway. Hansen, in the right-hand seat, did likewise. Then, surprisingly and against all documented procedure and good practice, Davis retuned his navigation receiver to the ILS frequency for runway 25 left, that being 109.9 MHz, with an inbound course of 251 degrees, the reciprocal of the 07 right inbound course, presumably to monitor the aircraft's progress in relation to the back course approach, which again they were prohibited from following. At this stage, it was clear that the crew had begun to improvise, engineering a completely unapproved solution to their current unexpected predicament. 3 minutes later, the approach controller issued the following clearance.
Scandinavian 933, turn left heading 080, intercept the back course to runway 07 right. You are cleared for the approach. Your position is 18 miles from Trout.
Trout being a navigation fix on the approach. Davis' readback was, not for the first time that evening, erroneous.
Okay. Right to 080.
Whether this was indicative of the growing stress which he was undoubtedly experiencing is open to debate. However, what is certain is that with his brief reply, Davis had again missed an obvious opportunity to inform the controller that he had no approval to conduct the approach for which he had just been cleared. The reason for the earlier speed reduction was now made apparent to the crew of 933. Having cleared Davis for the approach, they would hear the controller shift his attention to a Cardinal 67 Tango, a Cessna 177 type aircraft, also conducting the back course ILS approach to runway 07 right, which was now 4 miles from Trout, thus about 14 miles ahead of the DC-8. Noting that 933 was rapidly closing the gap, the controller once again instructed Davis to further reduce his aircraft speed, this time to 150 knots. As the cockpit workload increased still further, Davies queried the controller as to how much longer he could be expected to maintain 3000. The controller replied that 933 had already been cleared for the approach and as such was at liberty to descend with the published procedure. While this interaction was taking place, Hansen's recollection was that the aircraft was about 11 or 12 miles from touchdown, Davis believing it to be somewhat further out. Whereas these non-precision approaches are more routinely flown with the autopilot and autothrust engaged for as long as possible, specifically to reduce workload and facilitate better monitoring of the flight profile, Hansen instead immediately disconnected the autopilot, preferring to fly the aircraft manually, while at the same time calling for the landing gear to be extended. What had become an unexpectedly busy approach was now about to get a whole lot more complicated. With Davis having placed the gear lever into the down position, Hansen followed up by calling for the landing checklist to be commenced. However, due to the increased cockpit workload and external distractions on the radio frequency, his request went unnoticed. Now becoming preoccupied with the aircraft's position in relation to the landing runway and the altitude which still needed to be lost in order to attempt a landing, Hansen prepared to initiate his descent from 3,000 feet to 575 feet above mean sea level, the minimum descent altitude published for the VOR approach, below which the aircraft could not continue unless visual acquisition of the runway had been established. With his planned descent from 3,000 feet to the minimum descent altitude of 575, Hansen would have had to lose just over 2,400 feet, within 10 miles, or the equivalent of 4 minutes of flying time at 150 knots. Under these conditions, a descent rate of 600 to 700 feet per minute would have been adequate. Instead, however, he had articulated his intention to make good a constant descent rate of approximately 1,000 feet per minute, which, although slightly excessive, couldn't be considered unreasonable. So, with the autopilot now disengaged, he gently pushed forward on the control column in front of him, thus lowering the DC-8's nose as the needle on the altimeter slowly began to unwind. Out of the corner of his eye, Davis now spotted something which immediately put him on guard. Despite the landing gear lever having been selected down, only the two main landing gear were indicating locked in the extended position. In contrast, the nose gear light wasn't illuminated at all, meaning that unlike the main gear, it wasn't locked down. Or was it? If that were really the case, an unsafe condition would have been indicated, but confusingly, that wasn't what Davis was seeing. The nose gear was showing neither up nor down, with no alert being generated either way. Faced with diminishing fuel reserves, this is the last thing that Davis could have wished for. If cockpit workload had been high previously, the gear issue was now about to bring things to a completely different level. As the DC-8 continued its blind descent towards the landing runway somewhere out ahead, Davis called on Anderson at the flight engineer's station to help work through the problem with him. Davis' first thought was to recycle the gear in a hope that this would provide the crew with a quick fix to their predicament, but his efforts were to prove unsuccessful. Still gaining on the traffic ahead, the approach controller called out,
Scandinavian 933, reduce further to your minimum approach speed. What'll that be?
Davis keyed his microphone and answered abruptly.
126.
The controller's request most probably raised Davis' anxiety that a missed approach was becoming ever more likely. Yet despite his acknowledgement, compliance would prove to be anything but straightforward. In order to fly a speed of 126 knots, the DC-8 would have to be configured to flap full, so that the lift being produced by the wing would remain constant despite the deceleration. However, with no indication that the nose gear was locked in the extended position, selection of the trailing edge flaps beyond the 26-degree position would only trigger activation of the landing gear warning horn. This was an audible and unmistakable siren, indicating that the aircraft itself had now become concerned that the pilot, in preparing the configuration of the wing for an impending touchdown, had neglected to extend the gear, and Davis simply didn't want the extra distraction that this would bring. As such, when Hansen, as the pilot flying, called for the final stage of flap to be selected, Davis hesitated, without articulating to his first officer the exact reason why. Hansen, for his part, never noticed, and continued to decelerate towards the target speed of 126 knots, without the aircraft having been configured to do so. In so doing, unbeknownst to him, the margins to the stall were now slowly being eroded away. But indicative perhaps of just how quickly the pilot's workload was increasing, neither Davis nor Anderson, who were by now completely engrossed with the gear problem, had themselves recognised how Hansen was handling the aircraft. As such, just when it was called for most, the cohesive and effective teamwork of the three-man crew was starting to unravel. Turning in his seat, Davis instructed Anderson to check the relevant circuit breakers for the landing gear lights, and to check visually the nose gear downlock indications. Having checked the position of the breakers and realising that they all appeared normal, he removed his headset and moved forward, kneeling on the floor between Davis and Hansen. Reaching in, he carefully examined the landing gear light assembly. Whilst positioned in between the two pilots, Anderson recalled the captain informing the approach controller that should they be unsuccessful in resolving their gear problem by the time the aircraft reached its minimum descent altitude for the approach of 575 feet, then his intention would be to apply power and climb away, executing a missed approach with subsequent diversion to Las Vegas. This would prove to be the last radio transmission received from Scandinavian 933. Having checked the gear lights and noting nothing out of the ordinary, Anderson, in one final attempt at reconciling the status of the nose gear, got up from his current position and quickly moved to the rear of the cockpit. In the floor behind the engineer's station, and completely unnoticed on any other given day, was a small sight hole, no more than a couple of inches square. Now hunched over on all fours, Anderson lifted its protective cover and peered through. With the nose wheel being illuminated by an internal light fixed to its roof, what the flight engineer was looking for was sight of a gear downlock indication. These were nothing more than two separate decals, which visually aligned with each other, creating the appearance of one continuous line once the gear was actually in the extended locked position. In his post-accident interview, Davis recalled that by this stage, the aircraft was at approximately 1,200 feet, about 7 miles from touchdown, low on the anticipated profile, but not to the extent so as to cause him any great concern. At about the same time, Hansen recalled Anderson's call-out, having verified the decal below the floor, that the nose gear was indeed locked down, despite all the confusing cockpit indications. Davis, in response, placed the flap lever belatedly into the full position, and sure enough, the warning horn remained silent. His recollection at this point was that the aircraft was slowing through approximately 130 knots. Yet throughout all this activity and distraction, all three pilots had become completely blind to the much broader picture as to what the aircraft was actually doing, and critically, where it was going. Post-accident analysis would reveal that having vacated 3,000 feet, Hansen's rate of descent was to be anything but constant. Having articulated that a descent rate of about 1,000 feet per minute would prove optimal, in reality, and attributed to what the investigation team believed was him being distracted by cockpit events, the jet instead descended at approximately 2,000 feet per minute for a period of 26 seconds until reaching 2,200 feet, levelled off for a further 16 seconds before again recommencing descent at an average of 1,700 feet per minute. In a similar manner, it was noted that Hansen's management of the aircraft's heading and speed was likewise erratic and inconsistent. In short, instead of concentrating his efforts on simply flying the aircraft, Hansen had allowed himself to be sucked into resolving the problem, and being preoccupied themselves, neither of his colleagues had noticed. Davis' failure to clearly assign tasks with the onset of the problem meant that now no one was actually and exclusively flying the aircraft. Blindsided by all that was going on around them, none of the three crew members noticed the DC-8 descend through the approach's minimum descent altitude. As Anderson got to his feet in the rear of the cockpit, Hansen's last recollection was turning back to his instruments, only to observe the needle of his altimeter slowly approaching zero. With the aircraft's landing lights suddenly catching the breaking waters only feet below, at a mere 2 seconds before impact, the flight data recorder registered a positive G loading being applied to the aircraft, as instinctively Hansen pulled hard on the control column in front of him and added power, loads of power, in a desperate effort to arrest the jet's descent. But he was too late. Before being able to completely arrest the jet's descent, 933 impacted the waters of Santa Monica Bay, approximately 6 miles west of Los Angeles International Airport, at a time of 19:21 and 30 seconds local. With the aircraft orientated slightly nose up at the moment of impact, its tail section was first to make contact with the surface of the water. Such was the force that the fuselage broke into 3 distinct major sections. The largest, an 85-foot section, from the nose all the way back to a point abeam the trailing edge of the wings, remained afloat following the accident for a considerable period of time. It was eventually towed to a point off Malibu Beach, where it subsequently sank, but was later recovered and transported to the Long Beach Terminal Island Naval Shipyard, where it was examined and documented. The second centre section of the fuselage was approximately 42 foot long, extending from the trailing edge of the wing back to the production brake, just forward of the rear pressure bulkhead. The third, final section incorporated the entire horizontal and vertical components of the aircraft's tailplane. Both the nose and main landing gear, along with all 4 engines, separated from the aircraft at impact, and together with the mid and aft fuselage sections, sank immediately to the seabed, some 350 feet below the surface. Generally, the wreckage was found orientated along the extended centerline of the runway, covering an area with dimensions of approximately 1,250 feet by 800. Of the 45 passengers and crew on board the aircraft at the time of impact, 11, including 2 of the cabin crew, were presumed dead, being unable to escape the sinking wreckage. 4 others, having drowned, were subsequently recovered from the water, while 30 ultimately survived the ordeal, 13 of which were completely unscathed. Counted amongst the survivors were all 3 of the flight deck crew, Anderson, Hansen, and Captain Kenneth Davis. The 6 crew members who survived had all been located in the forward section of the aircraft, 18 of the surviving passengers also from the same location, while a further 6 managed to escape from the aft section before it sank. Those who survived consistently recalled only one impact on touchdown, which they likened to a very hard landing, followed by a very rapid deceleration. Quantities of water were forced up through the floor of the passenger cabin, deforming the floor area, most notably between rows 2 and 11, making evacuation extremely difficult. The surviving crew members evacuated passengers from the cabin onto the wings and into life rafts to await rescue. Survivors estimated that this time from impact until rescue itself was between 45 minutes to an hour. After 2 rafts had been loaded with survivors, the rafts were tied together and were paddled away from the left wing, passing in front of the nose of the aircraft. The second life raft, in tandem, was blown back against the jagged metal at the nose of the aircraft, where it was punctured. This raft collapsed with what passengers described as startling speed, spilling the people back into the water. When other survivors attempted to launch another life raft from the forward edge of the right wing near engine number 3, this life raft was also punctured by jagged metal and collapsed with again what was described as unexpected suddenness. Survivors described the impact with terms ranging from seemed not to be too hard to a tremendous blow. The flight recorder, which records the vertical acceleration loads at the centre of gravity of the aircraft, registered only 1.5 G. This load factor is considered extremely light for the events that took place and supports the analysis of progressive absorption of the forces placed on the aircraft. Additional support for this conclusion was the pathological observation that the injuries on the 4 bodies that were recovered should not have precluded escape from the aircraft, and the deaths were the result of drowning. The investigation team were quick to establish that all 4 engines were rotating under power at the time of impact. eliminating the possibility of engine failure pre-impact or indeed fuel exhaustion. In fact, when the gauges located at the flight engineer station were examined, they were able to deduce that there was just over 7,500 kilos, or the equivalent of 16,500 pounds of fuel remaining, as 933 had entered the water. Armed with transcript of their inter-pilot conversation on the flight deck and post-accident statements from all three surviving flight crew, their attention quickly shifted to the gear indications in the cockpit, and what they were to find would reveal a design flaw of the DC-8 which up until then no one had realised even existed. What they found was that the original design of the light assembly incorporated two separate bulbs, typical of any fail-safe critical system. The theory was that should one bulb fail for whatever reason, the remaining bulb would provide the redundancy required, thus ensuring continuity of safe operation until such time as the failed bulb could be replaced. The problem which the investigation team had now discovered was that the standard protective cover fitted over the bulbs was sufficiently opaque so as to effectively mask a single bulb failure. In other words, were one of the bulbs to fail, from the pilot's perspective, the indication on the lighting panel showed no appreciable change. Specifically in the case of Scandinavian 933, post-accident examination of the gear light assembly revealed that one of the bulbs had indeed blown. The investigation team surmised that this most probably happened sometime well in advance of the accident flight, but had gone unnoticed due to the opaque nature of the plastic protective cover. With regard to the second of the two bulbs, although the filament inside was found intact, further examination revealed a loose wire connection at the socket, which had obviously happened post-departure from Seattle. Now, with both bulbs effectively unserviceable, the fail-safe feature of this design had been undermined, meaning that although the nose gear had indeed locked in the extended position, a combination of bad luck and poor design had left the crew in a position whereby they were unable to verify this fact, at least by reference to the landing gear light assembly. In its summation, the safety board believed that the loss of Scandinavian 933 was caused by a series of distractions and aggravations that were cumulative in nature. These distractions were numerous: the delayed departure from Seattle, the headwinds twice as strong as forecast, the extended holding patterns dictated by the unusual traffic pattern for Los Angeles International that afternoon, the clearance to an intersection that wasn't depicted on the charts being used by the crew, receipt of an approach clearance that the pilot couldn't comply with, the decision to make an alternative approach to the one that was issued, and the failure to get a safe indication on extension of the aircraft's nose landing gear. All were sufficient to disrupt seriously the discipline and established procedural patterns of Davis and his crew. In truth, the failure of the good bulb precipitated the actions of both Davis and Anderson in their attempts to analyse and correct the perceived failure condition. These actions subsequently diverted Hansen's attention from his primary task of flying the aircraft, and also resulted in the breakdown of crew coordination and the ineffective utilisation of the relevant checklists. Of note was the fact that absolutely no altitude cross-checks were made throughout the entire descent, while Davis and Anderson attended to their perceived gear problem. In fact, it was subsequently identified that the version of approach charts used by Scandinavian Airlines for the VOR approach onto runway 07 right had completely failed to display a mandatory crossing height on the approach, that being 1,300 feet, as the aircraft crossed over the Del Rey intersection some 4 miles before touchdown. What this meant was that, being deprived of this fundamental and critical piece of information, Hansen's ability to readily identify the aircraft's position as being low on the ideal profile had been completely compromised. The chart had failed in its duty to inform him of what his altitude should have been, and he, for his part, had taken his eye off the ball. In light of all that was learnt, the NTSB determined that the probable cause of the accident was the lack of crew coordination and the inadequate monitoring of the aircraft position in space during a critical phase of an instrument approach, which resulted in an unplanned descent into the water. Contributing to this unplanned descent was an apparent unsafe landing gear condition, induced by the design of the landing gear indicator lights, and the omission of a minimum crossing altitude at an approach fix depicted on the approach chart. Exactly 1 year after the accident, on January 12, 1970, the board recommended that the FAA take corrective action to ensure detection by flight crew of failed indicator bulbs in the DC-8 landing gear position indicators. 5 months later, on May 22, 1970, the FAA reported they had investigated the suspected deficiencies and, in their opinion, the assessment of the DC-8 landing gear indicator system showed that the system performed its function, had an adequate backup system, and was in conformance with all other pertinent federal aviation regulations. It was their opinion that the landing gear indicator system provided the required reliability and aircraft operational safety. They did, however, recommend that all airlines which did not have a specific check of the indicator bulbs include such a check in their before start and before landing checklists. In what was a thinly veiled attempt to disguise the dismay at the FAA's response, the final report somewhat sarcastically noted that such belated action is often employed to compensate for improvements that should have been made in the original design of a so-called safety feature. Furthermore, the board stressed the fact that it was the responsibility of the manufacturer and the operator to be alert to the identification and correction of such problems before they became an accident causal factor. In this regard, both parties responded in a proactive manner. After the accident, McDonnell Douglas designed alternative landing gear indicator covers that would provide positive indication to the flight crew that one light bulb was inoperative. Scandinavian Airlines, for their part, retrofitted covers on the landing gear indicators of their DC-8s that would ultimately perform the same function. But it is perhaps what the report failed to incorporate, which arguably would be of the greatest importance. While rightly focusing on the technical aspects of the accident and the potential factors which could be employed to mitigate against any similar occurrence in the future, the role of the human was largely overlooked. The painful truth was that Davis, as commander of the flight, had failed to assign specific duties to each of his fellow crew members, and without such direction, collectively they had all gone down the very same rabbit hole. One can only assume that in these days which predated crew resource management training, the NTSB's failure to identify the need for such a radical rethink of training syllabi did nothing but leave the door open for such an event to happen again. And on December 29, 1972, some 3 years later, in the Florida Everglades, that's exactly what happened. This was the complete story of Scandinavian Flight 933, lost to the cold waters of the Pacific Ocean on the evening of January 13th, 1969.